Hey guys, I don't know if I was on the call or not, but I've been talking for quite a bit. And it looks like I wasn't on the call, so it's kind of interesting how that happened. So let me go through this again then. Happy Thanksgiving, guys. I don't know if I'm on the call still. Let's see. Okay, looks like I'm on the call now.
So let me
Okay, good. Okay, this is always a tricky situation because I'm using this software and okay, so let's go through the monologue again. Okay, I thought I was on the call. I've been talking all this time and I didn't know the things wasn't live. So that's interesting. Okay, so happy Thanksgiving, everyone. Welcome to Cloud Cover number 2. And I guess I have to repeat what I've said before. So again, I want to keep this short because I know you guys are eager to go to your family and prepare for Thanksgiving. I know I have to cook turkey, so it'll be interesting. It's always interesting to cook turkey once a year, and you kind of forget how to do it, and then you have to relearn and do it again. And you always try different recipes. So thank you again for joining this broadcast, and let's get on with it right now. Just to monologue this a bit, I just want to talk about why will people build on Züs is because because people want to transform their current application from whether it's a consumer app or an enterprise app into something that is using next generation storage, just similar to what the cloud went through, because it's easier to get on and use the cloud to build an app. In this case, it's not the ease. It's certainly the performance. We are better than traditional cloud, so there should be no excuse why you shouldn't use decentralized cloud. But the other aspect of it is privacy, and privacy is a big part, but also about getting hacks and ransomware security aspects of it. So the reason behind shifting from today's decentralized from today's S3 to decentralized S3 is because you want to have a lower cost of ownership. And when I say lower cost of ownership, is because you want to remove existential threats like DDoS attacks or ransomware or censorship, and that's why you want to move your platform, whether it's a website, whether it's a consumer app or an enterprise app, you want to move that over to a decentralized S3 platform. It gives you the ability to provide total ownership of data. That's something that doesn't exist today. When you go to any of the applications, they say, okay, we're keeping your data. It's all good. It's all private. It's all safe. I think Apple is the best way. They kind of claim that they say, we are the most private company. Even if the U.S. government wants to look at your data, will not let them look at your data. So this is something unnecessary now with the decentralized storage, because that's already available. That's already there now for people to transform their current app into using decentralized storage. So I want to kind of bring up this page is because that's why you want to build for the future. You want to transform your current application into using decentralized storage. Now. That may have been a lot of people, early adopters, wanted to do that, but as you know, the current solutions are not there for high performance, and that's something that we have solved. The current even the SIA and Storage, they have performance, but they don't have security, or they don't have quality of service component, which we have added. right? So in our case, the quality of service is very important, where you challenge every storage provider and they have to respond to the challenge within a certain amount of time, otherwise they get slashed. So not only do they don't get the reward, but also they get slashed. So it's a pretty a good protocol in the sense that it keeps everybody on their toes to make sure they're behaving properly, they're on a good data center. It's not a platform where you can put it in your laptop and then turn it off and so forth, and earn a little bit of income and then walk away. You cannot. This is like an enterprise grade storage. So we wanted to build an enterprise grade storage from day one, 5 years back. So this is something we have built, and now essentially the floodgates are open for developers, for the entire all industries to transform their application into decentralized storage, where they give ownership of data to the user. So now the GDPR is more effective. I would say is more. They can claim that they are kind of GDPR compliant because inherently the storage is decentralized. So that's why businesses will transform into decentralized storage. Now, how is that going to happen? Well, our strategy is go after the developers. So we're going to have several hackathons, and we're going to partner with several hackathon groups, and they will have their hackathons on a regular basis, whether it's a weekly or a monthly. Those details need to be worked out, but this is gonna be our focus in making sure our documentation is foolproof, is absolutely clear for people to engage with us, people to use our SDK to build on it. And also our apps, like if you look at, so that's the first layer, that let's get the developers immersed into our technology and be able to use it to transform their website or their blog page or their app, whether it's a consumer app or a enterprise app, right? So these are some of the things that we'll be doing, and you will be seeing that probably this sort of activity will become more transparent after pre-mainnet, right? And then after that, what we want to do is we want to then engage with enterprises and ask them to transform or shift their storage from S3 to decentralized S3. And why would they do that? Well, because there's security concerns. They need localization. They need the storage to be a multi-cloud strategy, multi-cloud solution where they're not dependent on one vendor. So those are, and of course the price of reads, right? So this is something that we are offering. We are allowing storage providers to provide a zero read price, so that it's a nice incentive for S3 users to move to decentralized S3. And that's, if you look at Wasabi, that's how they got a lot of business, because they can now offer these free reads. So you can do the compute on the cloud, but then use decentralized S3 to store your data. And that's the strategy behind Blimp, to make it easy. With no code change, enterprises can now store their data on S3, on decentralized S3, and get free reads, get performance, and of course security and privacy, right? Okay, so with that monologue in terms of why people will use our platform in order to store data, then comes the fun part of the storage economy. Once there's usage of storage, once people wants to store data, then then obviously we will have use for Chimney and storage providers. And once you have those things happening, then then you go to the earn. Then we look at how people will earn and how that dynamic plays into the role of the token price. One of the things I should mention is that we have updated the site. So thank you very much for all the feedback. There were some mistakes that was done, and also we also clarified a few things like the supply. I think we made it easier for people to now see what's going on. And we're in the process of also updating the tech doc and the token economics doc. I realize there are some mistakes. That's because of the format change that we had for the token economics doc, and we will get that sorted out in the next couple of days. So in terms of rewards, in terms of the token doc, actually, let's look at the token doc. You can see the token economics document. You have the revenue as a storage provider with all this data coming in. And let's say your price is 0, you don't get any proceeds from reads, but you're essentially getting proceeds from writes. Anytime data is written onto the network, they're writing to you, or you're participating as a validator to validate the challenge. So even if you don't write anything, you will get some income from validation. And of course, you get rewards from the network. So the income is essentially 4 sources. Reads obviously will be essentially 0 if your read price is 0. Write price will be based on whatever you desire the write price to be. And now if you look at the earn page, we assumed the write price to be discounted 50% relative to AWS. And that's our again, this is something you can set, but this is our recommendation that you set it at 50% AWS price. And if that's the case, then this is the rewards that will happen on the network. And I'll come back to this once I go through a little bit on the token economics document. So we talked about the revenue source for a provider in terms of rights and challenge validation and block rewards. The way the block rewards will work is that it's weighted based on the number of blobbers on the network. So the more the providers, the less the amount of reward each blobber will get, which is kind of obvious. And so that will determine how much you will get, but that really depends on how much pull there is on the storage. So as more data is stored, what will happen is this capacity, this state capacity will grow because there is more demand coming in. As there's more demand coming in, then you will see this number of blobbers grow, and the percentage staked on the network will be around. If you look at Ethereum, the staked Ethereum is around 13 to 15%. So we expect the stake to be around that. So let's say we keep the stake constant, then if we were to increase the amount of storage on the network, then total stake on the network increases. But that, if we hold that to 15%, then the price has to increase. So let's say we hold that to 15, and then, or 13% there. So the price will essentially increase. So that you can see how the dynamic would play out. And then if the price increases too much, then it will attract people because of the APR, high APR. So there will be more blobbers on the network. So the number of blobbers will then increase. And so it's a dynamic that will play out. But on average, what will happen is the more the data is stored, and you can play around with this. If you increase the price, of course the staking price will increase. If you increase the storage capacity per server, it will increase. And also it depends on what is the rental cost per TB per month for the data centers. that's something we're gonna talk to different data centers and ask them to be around $3 per terabyte per month, so that there's a healthy profit margin for the storage provider, for the blobber on the network. And it's kind of a win-win. A lot of people say, okay, price, there's inflation, but I don't quite buy the inflation part, because the electricity consumption for a disk is about the same, whether you're storing 50 TB or 100 TB. In fact, it's actually a win-win for the data center if the price is lower, because that will allow more capacity to be moved from traditional storage into decentralized storage. So, I would say the data center providers would be encouraged to lower their cost to get more business. So again, as you increase the number of capacity, the amount of capacity, let's say it goes to, I don't know, let's say it goes to exabyte, right? I think Filecoin has about exabyte of staked storage, but their capacity, their consumption is very low. We don't expect that to happen, because our token economics is tied to the consumption. And so the usage, we assume the usage to be 50% of the state capacity is the allocated capacity, and out of the allocated capacity, the usage, the actual data that's on the network will be, the assumption is 50%. If that's the case, then that is amount of that's the amount of reward, and that's the amount of token staked. Now we know 200 million cannot be staked; it needs to be around 15. So the price has to increase to so that it's 15, around 15 or so, 15, let's say 15 million, right? So 15 million, because we want the staked percentage. If you look at Ethereum, the staked ratio is around 13% on their network, and with 100 million tokens in circulation, we expect this to be around 15 million for the long period of time, because most of the tokens on the even the 100 million, most of it is within few hands. So so we expect that to even lower. I would say it'll be more like 10 million. So it'll be more like, so you can see how if we can get storage, exabyte of storage on the network, if you can get that level of storage, you can see the price rise and the earnings potential to be very reliable, high APR. And that's the point, right? So, but how do we get stored data on our network? And that's where the hackathons come in, and we expect in the hackathons to drive usage on our platform. And once there is usage on our platform, and we expect the decentralized S3 to be the primary driver for high storage. I mean, if you look at studios, if you look at hospitals, they have a lot of data. X-rays are like 1 gigabyte or several gigabytes per image. So those need to be stored efficiently, and the best platform for storing X-rays and hospital data would be a decentralized storage, because you get privacy, you get to share this private data with your friends and family without going through HIPAA regulation and things like that. For studios, for people generating videos, high quality videos, high resolution videos, these are something, or high resolution images, or high resolution NFTs with video explainers, and things like that, which is what we are enabling on our network. They need to store all of that data, and we expect that data to be very high. And then of course there is Vult, right? If you look at if right now, if you look at Google Drive and OneDrive and Dropbox, everybody's using one of these storage solutions. If once they start seeing Vault, think about 8 billion people, right? If we get a percentage of that using Vault, if we get 1 million users using Vault and the store even 100 GB of storage, that's in the zettabytes. So I think we expect the Vault to be a driver of storage. We expect Blimp to be a driver of S3 storage, and we expect our SDK to basically build for the future. We expect people to use our platform to build social apps, whether it's the next metaverse gaming app, or if it's the next Facebook or Twitter app. They can build all these apps, or Instagram or Snapchat, and all of these apps use now GIFs or little videos that are high res, and they have a lot of consumption of data. And those data is something that will come to our platform if they, once they use our SDK, because that way they give control and data ownership to their customers. So that's basically driving the usage, and once that usage comes, then the earnings will basically come. So as you can see, right now, even we expect 400 blobbers to be up and about, because otherwise, if it's less, let's say there are 200 blobbers or 100 blobbers, the return is very high. So it will encourage people to basically at least have 400, even at this price range, in the 20 cents price range, right? So that's kind of the that's what I want to talk about in terms of how the consumption of storage affects the price of the token, and the token economics associated with that. Now, in terms of how the selection process works, in terms of the rewards, I think I've talked about the ways you can earn income, but in terms of how the selection process happens is detailed here. By the way, I should note that for miners and sharders is 8.5 million tokens, which is divided up among 141 miners on pretty much an event basis. And then you have blobbers are rewarded 7.5 million, and then this supply essentially decreases by 10% over time. So if you look at the supply, I believe, if you look at the supply, you will see that you start off year one basically status quo, which is 200 million. And then we basically in end of year one, we end up with 220 million. So this is the mine generated by the network. This is given out as free storage. 2 million is free storage, and then we have miners and sharders for 8.5 million, blobbers and validators 7.5 million, and we have Wi-Fi, and this is something that we will do for next year in Kilimanjaro. Prior to Kilimanjaro, we will have Wi-Fi. We'll work on getting Wi-Fi platform up as well. It's all coded. It just needs to be sorted out and done and integrated with Magma. So that's something we will work on later on next year. And if that's the case, then basically that will be the outlay, and it's 20 million for the first year, and then it declines by 10% every year thereafter. And that's why when I said the percentage, if you look at the token, most of it is the token sale is 60 million, and then there will be probably around 100 million out there that is really in circulation. But I don't expect that to be that much. So that's why that's why I was talking about earning in terms of percentage staked on the network won't be more than 15 million. We don't think. So I was gonna talk about the rewards. Yeah. So let's go back to the rewards. So the rewards, how do you get the rewards? So as a blobber, you're basically in a group. You're assigned a group. And then, and if you leave the group, then it's basically shuffled, and another blobber basically takes your place in that partition. But then this partition is chosen randomly. So let's say there are 100 blobbers, each partition is 10 blobbers. Then your partition gets selected 1 out of 10 times every block. And then once you're selected, then you are rewarded with the reward, the block reward. And that reward is shared among the blobbers in that partition, depending on your weight. So let's say you have 30% weight, then you get 30 ZCN. If there are 100 ZCN to be shared within that block reward. Now, how do you calculate the weight? The weight is really based on two things. One is your goodness factor, how good you are, and then how much you have staked on the network, and how much basically staked usage, how much usage you have. So it's not about just staking, but it's also usage. So if you have 0 challenges, let's say you have no data on your server, then your weight will be essentially 0. So you need basically people to store on your server. It's not just about stake. And how do you get people to store on your platform? It's because you have a goodness factor of 1. 1, I think, is the maximum, or something to that effect. You have free reads, so people will basically choose you, and then you also have very good network that allows reads and writes to happen. So it's not just about having a server, but also a good network that allows good reads and writes to happen, and also that allows your challenges to be successful. Because remember, challenges need to be done within a certain amount of time, so you need to be on a reasonably good data center. Okay. So yeah, and that's what the token economics document is about. I mean, this is kind of a dense paper, but we have simplified, and we have kind of simplified it down definitely a lot on the website, but also on the paper we have tried to keep it simple and go through one by one in terms of what happens in terms of challenges, passing challenges, fail challenges, and then how the weights are calculated. So you can look at this, and in terms of like what sort of function would it be in terms of how much I would not get. Like 1 is the maximum, and then 0.25 or going towards 0 in terms of if your read price is high. So if your read price compared to your write price is high, then obviously you will have less rewards. And then this is about fair usage. So fair usage is saying that if I have 20% of the network, so we have chosen the parameter to be 20%, which means my reads are about 20% compared to the writes. So if that's the case, then basically we'll get the maximum reward weight. And generally, if you look at most of the network, it's around 80-20. So you have 80% writes, 20% reads on any server on average. So we expect this to be around that. And again, there are some sensitivity parameter to make this sharp or this flat. And this is something that we will kind of tune before we go to mainnet. Okay, so I think that's pretty much what I wanted to talk about. The other thing I wanted to mention is that our load test, I just wanted to give you some information on the load test. So this is the active set load test that we're doing. As you can see, we have several phases: wallet creation, transaction allocation, storage allocation, and storage transactions. Right now, all of them are passing. We have all these functions. So for each phases, we have different functions, and what we do is we do concurrent. So we have concurrency of 20 here. That means 20 wallets or send transaction or port transactions are happening at the same time. So that's a concurrence of 20. This is the finality stats of different phases. As you can see, it's pretty tight in terms of the duration of the finality. It's around around 225 milliseconds. Of course, this will be it'll be almost double that for a larger network. This is actually a smaller network. The network size is around 3 miners, I believe. Let me see. Yeah, this is around 3 miners, 3 sharders. So that's what you're looking at right now. This one here. Okay, so this is the finality stats. This is the block sizes, how many transactions in a block. As you can see, the maximum that reached was 27 in a block. And then we have the allocation stats on challenges passed and failed. So most of them are passing, which it should. We also have data in terms of challenge timings. It tells you how long it takes the challenge to be completed within each blobber. So you can see different blobber challenges in terms of success, expired, and time, how long it takes for it to submit. So we kind of track how long it takes for the challenges to be submitted and then responded and then validated. So this is the write markers. As you can see, how many write markers, there's like 28,000, 0 failures. Same thing with reads. Challenge, there are some failures, and this is something we're gonna fix before we go to mainnet. We are optimizing that code. So that's on the smaller network, and now I'm just gonna briefly show you the larger network. So this is the larger network that we are also simulating, where we're simulating as well as chaos. So so this is a 90 miner and 30 sharder network, and you can see all these red ones are the ones that are down. So we're simulating chaos where these servers go down randomly, and we're load testing on this network where these servers are randomly going down. It's like 6 servers at a time. So 6 servers have gone down, and we're putting 3 miners on one. So there's like 24 miners, I guess, are down. So out of 90, 24 miners are down. And we're still, if you look at the chain stats, we're still going at a pretty high clip at 400 milliseconds. So this is what I said. We expect the performance to be around 400 to 500 milliseconds in terms of sub-second finality, because we want to achieve sub-second finality. So we'll try to see what this number will be on for pre-mainnet, because now you're dealing with network issues, how far the servers are away from each other. So we don't know how that's going to translate. But right now, if you look at the testnet load test, it's looking good. So this is at a very high TPS. By the way, I should note active set. As you can see, we have different runs. So each run, basically, we increase the TPS. So now run 500 is 320. So 320 current transactions. And I know we're doing this is still in progress, actually. This is still running 640 concurrently. So this one is 800. So this is very high concurrency. And as you can see, we have very few failures. Again, failures meaning transaction didn't go through. So most of the transactions are going through at 800 TPS. So this looks very promising. This looks very good. And we are, looking, there obviously, if you look at our GitHub, if you look at our GitHub, and if you look at, some of the issues that we have. By the way, I should note that, what you see in the public are the public reports, but we have a lot of repos, as you can see. There's a lot of action going on in the private repos that you are not aware of. So the zero chain repo, as you can see, there's 116 issues. We expect, most of them to be done prior to pre-mainnet, at least the more important ones. So if you look at the ones that are not post-mainnet, there are some, there are basically 50 issues that we need to sort out. Most of it is going to be sorted out prior, or most of the important ones will be sorted out prior to pre-mainnet. and they are mostly to deal with the database, event database, which basically is what Atlas is all about in terms of getting the data of the network. All right, so what I'll do now is I will go back and I will look at the chat and see if there are questions. Open the floor to questions. Okay, I see some questions already. Okay. Abdul is asking a lot of questions, so let's see. I think so. Why does the maximum price of ZCN only $10 on the site? Well, that's because it's hard to change the number. That's why. It's nothing. It's hard to change the number, especially now. It's at 20 cents, so it's hard to change it at the low end. But we can change it later when we are at a higher number. Then we can certainly change that. Let's see. Where Züs where Züs will be better than Filecoin is another question by Abdal. So the way I look at it is Filecoin is more archive storage, so we don't necessarily compete with that. But we're in a different category. We are in the S3 category. So if you look at AWS, they have archive storage, they have S3 storage. So we are competing essentially in S3 on the S3. So the better comparison would be SIA or StoreJ. Okay, what will be the estimate price for ZCN mainnet? Do you believe it'll be 25x? Well, I cannot answer those questions, Imran. So Imran asked what will be the estimated price for ZCN token. Again, I don't, obviously I cannot talk about price. I cannot speculate on price. But you could, one of the things what we have done is on Atlas, you will see how much tokens are staked. What's the relationship between token staked and the token price, and then you can ascertain and you can also see what's the historical data on data stored on our network, and then based on that you can make assessments similar to what you guys can do on Ethereum, right? Ethereum, you can tell from the number of transactions, in terms of what the fees would be and how much and how much tokens are staked on the network. You can determine what the reward is. So it'll be kind of similar, and that's what we have done on Atlas, and that will give you very accurate data. The one on the calculator on the website is an estimate. It's an estimate based on several assumptions which we have pointed out. Okay, so in terms of partnerships, so there are a lot of questions about partnerships and so forth. So our partners will be primarily hackathon partners for now, because we want developers to be engaged to build on Züs. And then later on, it'll be enterprise partners that would that will basically go out to enterprises and move the current S3 storage or migrate the S3 storage to decentralized S3 storage. But right now our focus is on hackathon partners, and you will be seeing them shortly. Again, this is hackathon partners is one. The other is actually people who build a blockchain developer companies. So we're also targeting them to be part of our ecosystem so that they can help with the transformation, the decentralized storage transformation of apps. Okay. Okay, Phil511, are any of our listed partners planning on using storage on mainnet launch? Well, it depends on where they are in their process. So, this is something, again, we don't have that timeline. We can only focus on our timeline, which is mainnet, and the mainnet will be after pre-mainnet. The pre-mainnet will probably be a month to 2 months, and then we will have mainnet, and that's the plan. And as you can see from our load testing, it's going really well. We have very few errors, and now it's about closing some of the issues that we have, merging them, and making sure that all of them pass these tests. Now that these tests are passing, it's a very good sign, because now there's few more features left to be merged in the code, and then we're pretty much ready then to go to mainnet. Okay, Tiago, question from Tiago, or Glib. When challenged, how quickly does an online active blower pass challenge? So right now we set it for 3 minutes, but we want to lower that. Once we optimize the code, we should be able to lower that a bit. So right now it's set at 3 minutes. I'm just scrolling up to see if there's any other questions. Okay, yeah, why we're running late? Okay, sorry, because I didn't press go live. So this software allows you to basically click on a broadcast and then start streaming. So when I clicked on start streaming, I thought I was already live, but that wasn't the case. You have to press the go live button. So now that I know, next time there won't be any delay. Sorry about that. All right, so it looks like those are all the questions that we have. Again, thank you very much for taking the time and for this AMA. Happy Thanksgiving, and we'll see you next week. We will discuss, most likely we'll discuss an app. We don't know which app we will discuss next week, but it'll be one of the apps that will be showcased. So till next time, thank you again for joining us, and happy Thanksgiving. So the one final question that has come up is from Mario Gomes. What TPS can the network reach? Yeah, the transactions per second is something I think we can reach probably 1,000 fairly easily, I think, for send transactions. Again, it depends on what kind of transactions you're talking about. If it's a smart contract transaction like allocation, then it's restricted to probably around 100 or so, because some transactions take about 10 times longer than a simple transaction. And the simplest transaction is when you send tokens to somebody, and that we can do about 1,000. Okay. All right. Thank you, guys. Till next time. Bye-bye.